Assalamualaikum and good evening. I'm ABDUL bin HUSSIN from Group 3. We'll explain our project about expert system for reaching destination using SWI-Prolog and Java. Firstly, thank you for all for view the video. Okay, I will start. Abstract. Now the efficient travel is daily challenge and effective time management, cost and convenience. Traditional method rely on personal judgment and limited information, and expert system can be recommended transportation option based on distance, budget time, and preference, improving decision making and reducing uncertainty. This study discussed a design and expert system using SWI-Prolog and Java to advise user and optimal travel choice and provide the overview of SWI-Prolog syntax and integration with Java for user-friendly interface. For next, introduction. In artificial intelligence, the expert system provides a different approach by using the rule-based structure to simulate human decision making. In expert system consists of three core components. The first component is rule-based. The rule-based store in the rule that define how decisions are made. Example, if travel time short and cost is low, then suggestion is working. And the second component is interface engine. This interface engine evaluates user input fact again this rule to derive conclusion. The third component is end user interface. The user interface allows user to interact with the system, input their preference or constraint, and receive advanced expert system from programming language like SWI-Prolog. And the next is methodology of SWI-Prolog. Methodology with SWI-Prolog will include with four category is define fact about location and distance, define rule and related minute, query the system about the observed weather, let Prolog interface infer the possible condition. First, user will enter the location, distance and weather. The program calculate based information given by user. The program show the result, example travel with taxi. That's my explanation. I will pass to AMIRA for next presentation. Thank you.
Hi, Assalamualaikum. My name is AMIRA with AZIZI. I will present about system design and implementation. Framework. SWI-Prolog user interface is command line based, making it unsuitable for modern application. Limitation. It struggles with traditional flow control and complex mathematical operation. Solution. Developers use the Java archive file to connect Java with SWI-Prolog. Strategy approach. SWI-Prolog handles logical reasoning while Java is used for GUIs, mathematical computation and business process management. SWI-Prolog uses a command line interface which isn't ideal for modern application. It also has difficulty handling loops, if-else condition and complex operation. To solve this, developer use JPL.jar to connect Java with SWI-Prolog. In this study, SWI-Prolog handles logic while Java manages GUI, graphical user interface, math tasks and business process. Rule-based system. A rule-based system is a type of knowledge-based system that uses a set of rules to make decisions or solve problems. A rule-based is the core component of an expert system containing structured rules that guide decision-making. It mimics human reasoning by applying predefined rules to input data, allowing the system to infer conclusion. Using the forward chaining as logical process approaches, the logic architecture of the rule-based follow a structural decision-making process based on condition related. Example, the following rules are the diagnosis rule for reaching a destination. Distance, determine whether to walk or drive based on distance and time constraint. Location, if driving, the system defines the mode of transportation based on location. Weather, if walking, the system adjusts recommendation based on weather condition. The system takes in details like distance, time, location and weather, then follow rules step by step to decide the best action. Each rule builds on the previous one to keep the logic clear. If multiple rules apply, it prioritizes the factor like making adjustment for bad weather when walking. User interface. This UI will guide users in selection the best mode of transportation based on distance, time, location and weather condition. And this one will be explained by my other team members. So for the conclusion is, by integrating the system with Java, users can easily interact with an intuitive interface and also possible to obtain preferred routes based on various conditions, thereby reducing traffic congestion in specific areas due to the even distribution of vehicles across the road. Additionally, the system is designed to optimize time management for users while focusing on creating a sustainable application that offers high extensibility and scalability. And that's all from me. Thank you.
Assalamualaikum and hi. So today I want to explain our code, which is a Java program, a GUI with a Prolog expert system code. So this is our previous Prolog code, and we already customize it into this. But before that, we need I will add some rule. From Java. So code is means M means of transport. M. So this rule is to added to help the Java program query the transport recommendation more easily. And this rule actually is for remove all user input facts from the system. It's useful for resetting the session before a new query and ensuring that all inputs don't interfere with new ones. Okay, so this is our Java program. Provides a graphical user interface (GUI) interacting with a Prolog expert system, and it allows users to load a Prolog knowledge base, run queries, and view results within a user-friendly interface. So this is our code. For the first rule, which is this rule, this rule is to load the Prolog file travel underscore expert.pl, which contains the rules for deciding how to travel, and if the file can't be loaded, an error message is shown. So next rule is this. This avoids mixing all inputs with new ones. And so this rule is to, after the user enters their travel information, such as distance, time, location, and weather, this part of the code takes those values and insert them into the Prolog knowledge base. Okay, we do this using asserts, which is a Prolog command that adds a new fact dynamically at runtime. And so this rule is this checks whether the system suggests driving or walking. And this rule this fetches the recommended action like walk or take a taxi. So that's all from me. The output we will show for the next video. Bye.
Hi everyone, my name is ANNESSA. So I'll be going to explain how do we run our program using JPL. Okay, so first thing first is we need to find the location in order to create the compile code so that we're able to run using the JPL. So in my case, my SWI-Prolog application file location is under downloads. So I save my file here. So what we need to do is open the file and then go to library. And then we need to save our Java and also our PL files, which is our Prolog code, in the same file. And then we're going to park under the library in the SWI-Prolog application file. So here is my Java and also Prolog code. So when I open it, all the files are combined in the same location. So up here is I just need to copy my locations. Okay, so now we need to create the code for the command. Okay, so here is my two code to do the command and run the file, the Java and Prolog using JPL. So I have two codes right here. First code up here is to compile the Java code, and then the second code right here is for run the compile app. Okay, how do we run the system using JPL is we type command, so we just type cmd and then enter, and then we just need to insert our first code just like just now and then click enter. So in my case there is a warning because my application version for both Java compiler and SWI-Prolog are different, so that's why there is a warning. So we can just ignore that, and then we have we enter the second code. So the GUI for both Java and Prolog will appear. So for example, we put 6 and then the timing we can put 10, and then the location will be the city center, and maybe the weather is bad, so we click button analyze, and then the system will show you the result. So that is all for me. Thank you.